Okay, this is 7.4 more and 7.3 more. Okay, and this is still rational expressions. Hope you guys are doing well. Okay, so rational expressions, we were doing adding, subtracting, simplifying, multiplying. Let's see, do you remember the initials? The initials from 7.4, which was the adding and then subtracting. So let's see if you can remember the initials. I showed my mom the video, and they were laughing at my silly Daffy Duck. But 2 days later, she said, "Oh, I wonder if I remember the letters." And then she told me the letters. She remembered the top and the bottom. She, for a moment, was thinking about the Daffy Duck eats Kentucky Fried Chicken. So she finally remembered the KFC on it. But that was pretty impressive. I was pretty excited. Okay, and then she didn't practice any of them. Okay, so adding and subtracting. Let's think of the letters. So what are your letters? Okay, it's negative, FM, DAF, KFC. You don't have to write the numbers out, but you do have to write on the top here, you have to write bottom. And on the bottom 3, you have to write top. She was so cute. I was thinking she was going to say KFC, and she said, "Oh, and the bottom 3 have the word top, and then the other 2 have the word bottom." And I was thinking, oh, I was thinking of the letters, the KFC. Anyway, so she was pretty good. I was pretty impressed. Okay. So this is for adding and subtracting. You do all the steps. Okay, so adding and subtracting, you do all the steps. Simplifying. Multiplying. Do you remember which steps you do? You only do 2 of the steps. You only do the FFC step. And then what do you do for dividing? What do you do for dividing? So there's one thing you do first. You flip the second one, the one after the division sign. So flip FFC. Okay, and then you do have to remember your factoring. Okay, so you do have to remember your factoring. You have to remember your difference of squares, your greatest common factoring, your check factoring. Those are the trinomials. Okay, so let's see. So let's try one. Okay, so let's try this one. Let's try 2x plus 6 divided by, let's do x squared minus 4x plus 3, and then minus, let's have 5x, let's see, over, I'm going to keep the same denominator. Okay, we're going to do the steps, but we're going to keep the same denominator and then see how that works. So that's going to be interesting. So 9, let's see, minus plus 15. Actually, I don't want that to be a plus 15. I want that to be a negative. No, I want that to be what I put already. So what did I put? I put plus 15. No. I'm so indecisive. Okay, I'm so indecisive. I want this to work out like a beautiful question that I have planned. Okay, let's try minus 3. Okay. So the first step, okay, the first step is minus. So what did the minus mean? What did the minus mean? Okay, so minus means change this negative to a plus and then distribute the negative on the top. So check mark, we did the negative. What does F stand for? So try to think of what F stands for. Now, are you supposed to factor the bottom or the top? So this is why we label it, because we need to make sure that we factor only the bottom. So don't factor the top, even though the top looks like it factors. So let me put the word check, line, 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 line. How can you multiply to get 3 and then come out to be 4, xx? What about 3 and 1? You think 3 and 1 would work? Xx, 3 and 1? I think 3 and 1 would work. And then what sign to get a negative 4? Okay, so to get a negative 4. To get a negative 4, maybe both negatives. 2x plus 3. And don't factor the top. Factoring the top is not till I'm writing over here on the left, factoring the top is not till the very, very last step. Okay, plus, this one factors the same. Okay, so negative 5x plus 3. Okay, so we look at this, and I factored the bottom. Now the m step is my brother. I was showing my brother. It was so funny. It's funny because he and my mom, they're like, oh, we want to figure out how to do it. But they were cute, so that was funny. Let's see. I showed them at different times. And then I showed my best friend, and I showed his son, and it was funny. Okay, so what do you think? This is me. I'm yellow. And the blue is my brother, always the denominators, because remember the m is to the bottom only. So I need to match. But my brother and I already have the same things, so I don't do anything. So my matching, I could put NA over here, because I already did it. They already match. Distribute. Well, distribute is NA. There's no distributing because there was no matching. Okay, how about A? What's A stand for? Okay, A is add, and it says A the tops. So you're adding the top, and you're K-ing the bottom. What did K stand for? Try to think of what K stands for. That was keep the bottom. So I have this. That's K. F. What's F mean? Now we're at the bottom, though. So factor, this is factor the top. So finally, we're ready to factor the top. This one doesn't have a squared, so it doesn't factor as a difference of squares or any of that kind of factoring, but it might factor with the line and the parentheses. Okay, so the line and the parentheses. So what number do you know goes into 3? Okay, so 3 and 9. What number goes in evenly to 3 and 9? I would say 3. And then since the negative is in the front, you're really supposed to put the negative when you do a greatest common factor if there's a negative in the front. We saw that before with factoring by grouping. And then you have to see what's left. I'm going to change color so it's easier. I need negative 3 to multiply by something to get negative 3x. Then I need negative 3 to multiply by something to give myself positive 9. Okay, so negative 3 times x, that would go here. Let me do that in red. I think red would be easier for you to see. So x. And then negative 3 times negative 3 is positive 9. Some of you won't do this stuff on the side because you already know how to do greatest common factoring. But if you're having trouble, writing the things at the side really tell you. The GCF goes here. And then these letters go here. And then these answers are what end up over here. Okay, so I did the F. I did the A. I did the keep. What's C stand for? Now, I said cancel. So for me, C means cancel. But somebody in 4th period said cross out. That was better. Cross out. So we're going to cross those out. So it's a very good description. Okay, so this is the final answer would be negative 3 and then x minus 1. Okay, so this is, we'll call this example 1. So on the last video, I showed you all the most complicated types. So now I'm going to show you the ones that have less things to do. They're a little stranger, okay, but you're going to understand them. You're going to be able to figure them out. It's very important to have done the first video and do the first video's practice before you keep going, because otherwise you're going to get confused. That's why I made it into 2 videos. Okay, so let me do the next example. Example 2. Okay, so let's say we have 5 over x plus 3, and this time it's a plus. And then on this side I have, let's say 5x plus 10, and I have x plus 3 squared. So what do I do if I have x plus 3 squared? Okay, so remember your steps. Okay, so you definitely want to write out your steps each time. Okay, bottom. Nope, that's from the top. Hold on. The bottom is the top, and the top is the bottom. Maybe just put B and T. That could help. Okay, so negative. Negative means if this is a negative in the middle. It's not, so I'll just put no. Okay, so F. F the what? So it says F the bottom. Well, that thing is squared, so there's not really a factoring. But what do you think about writing it twice? I feel if I write it twice, it makes more sense with the next step being my brother. Okay, so now I'm on my brother step. Let's do that in red. My brother. Okay, so if you look at me, I'm yellow. And you look at my brother, who's blue. How are you going to get me to have what my brother has? So remember, the saying is, I want what my brother has. I'm changing colors. So I want what my brother has. Now he has an X plus 3, so I call that a PlayStation 3. So he has a PlayStation 3, he's in blue. But you know what? He has 2 PlayStation 3s. Now I don't know why he has 2 PlayStation 3s, but I only have 1 PlayStation 3. So I want another PlayStation 3. Okay, so I'm going to put a PlayStation 3 right here, an X plus 3. Now, if you ever put anything at the bottom, you have to also put it at the top. So I often will write it in another color or maybe dark. Like you can make it really dark with your pencil so that you can really train your brain to see that you put it on the top and the bottom. Lots of people will put it on the bottom and they'll forget to put it on the top. Okay, so I did my matching. Now what about my brother? So my brother is in blue. He looks over at me and says, oh, she only has 1 PlayStation 3. I have 2. Well, now she has 2. So we're equal now. Okay, so we're equal. So I want what my brother has. D, distribute what? That would be distribute the numerators. In this case, there's only one numerator to distribute, so 5x plus 15. And then I have my x plus 3, x plus 3. And then I have my 5x plus 10. And I have my x plus 3, x plus 3. Now I have a common denominator. Okay, so those are the words that you're used to from middle school and elementary school. So now I have a common denominator. So I add the tops. So add the tops means add the tops. So I add the like terms. Okay, so I add the like terms. I add the 5x to the 5x. And then I add the plus 15 to the plus 10. That's plus 25. Divided by K. What did K stand for? We added K a couple years after the first one. So K, what was K? So K was keep. That stood for keep the denominator because sometimes people would want to write all 4 of them, which is possible with multiplication, but not with addition and subtraction. So add, keep. F. F what? Okay, so F the top. So F the top. Okay, so the top, what kind of effing should I do here at the top? How about factoring? What kind of factoring? Greatest common factoring? Yes. So greatest common factoring, that's where you put something in the front, and then you have to figure out what the rest is. Okay, so think about that. Do you know any numbers that go into 10 and 25 evenly? Put that number in the front. It's called a GCF. Okay, I'm doing a GCF, 5. Then you have to think what is in the gap. Okay, so it's, I need to have 5 times, let me change the colors on this one. Okay, so I'm trying to do 5 times something equals 10x and 5 times something equals 25x. I'm trying to backwards distribute. So 5 times 2x would go in the first spot, and 5 times 5 gives me the 25. Okay, that was F, the top. And then C stands for, what did C stand for again? Okay, so C stands for cancel. Nothing cancels. So that's my final answer. So this is an example where I have 2 things, and I want what my brother has. I do want both of them if he has both of them. Okay, so let me show you another one. You can always pause and go back, or if I'm going too slow, you can speed me up. So on YouTube, it's super cool. So you go to settings, you can make it more clear. You can put it on like 720p or 1080p, depending on what kind of device you're on. And then you can also speed me up. So I found a way, and then it says like ×2, and then I sound really fast. And then there's also a slow, like 0.5, and then it goes slow. Okay. So you're like, I just need a skip the stories button, Miss Nichols. Okay. Somehow the way that I'm uploading these videos, it's not letting you comment on it. So if you need to comment on one of them, just send me a text message. So that's very disturbing. I think they're trying to protect you guys because I have to put that I'm making it for students. And so since some of you are under 18, it says for kids. So I should look up kids because kids doesn't sound like 17, 18. But just in case, or 16. So I think that's why it's not letting you comment. So I'm trying to figure out how to fix that. But anyway, right now it's not. Okay, so example 3. Now example 3 is going to look a little bit different. Okay, so example 3 looks different from anything that we've done before. Okay, so let me show you one. Let's see which one I want to show you. Okay, I don't like any of those in the book. That one's not exactly what I want to show you. Let me show you this one. There's one in the book that's not too bad. I'll just change it. Okay, let's say you have 2 over 5x, and you're subtracting 3 over, let's say 6x. Let's say 13 over 6x. So I'm going to write my list down. Negative FM, DAF. KFC. This is for the top. This is for the bottom. Look how fast that is. It's so fast. And it gives you a list of all the steps in order that you're supposed to do. It's like the best thing in the world. Okay, minus. What do I do with the minus? Okay, I have to change it. So you change the minus to a plus and then put a negative, distribute the top only all the way over there. Okay. Now, if I do, I have to factor the bottom. But they just don't feel like factoring. So I would say no on the factoring. This one I just did. Now, I do have to match. Now, there's 2 options here, and I'm going to show you both options. Because there's no plus sign, this really is 5 times x and 6 times x. So they're really separate. So when I do I want what my brother has. Hold on. My brother came out yellow. Okay. When I said I want what my brother has, technically my brother does have an x. And because it's not x plus 6 or x plus 5, that's its own separate thing. It's like an x plus 0 and another x plus 0. So those are actually their own thing. So one way you can do I want what my brother has is the 5x looks at the 6x and says, hey, what does it have that I want? And the answer would be a 6. Okay, now it also works with a 6x. So I will show you that a different over here. So I'm going to put alternate way, and then we'll do that one afterwards, okay? Because both ways work. It just depends which way your brain thinks of the day that you're doing it. Okay, now look at your brother. My brother is the blue one. So I'm standing where the blue is, and I'm looking over at the other side and saying, wait, my sister, that's me, has a 6, has an x, just needs a 5. So let's make times 5 times 5. And then this is 12 over 30x plus negative 65 over 30x. And now they do match. So that's the whole purpose of the matching. You can match by multiplying. You can never match by adding, but you can match by multiplying. Okay, and that's what I always do in the other color. D is distribute. I just did that. A is add. So you add the numerators. So negative 65 plus 12, 3, 5, negative. Okay, so negative 53 over K. What was K? Okay, K was keep the denominator. So keep the denominator. F, factor the top. Does 53 factor? I don't know any numbers that go into 53. So I would say that's a no. And canceling, that's a no. So that's it. Now I want to say that's the easier way, but it's only the easier way if that's the way you see it when the problem comes out. So there's another way. Okay, so there's another way. It depends what you see. So say you have 2 over 5x, and then let's say you changed it to the negative 13 over 6x. So we're here. And what happens if you decide, hey, my brother has a 6x, and I don't? How about if you wanted to put a 6x here? What would this one need then? What would the blue one need? The blue one would need a 5x. This is definitely legal. Distribute the tops. That's 12x over 30x to the second, because you add exponents when you're multiplying, plus negative 65x divided by 30x to the second. Okay, so that's legal. Totally legal. No problem. We're still going on the steps. I just did the match step. I did the D step. I'm now on the A step, so I need to add. Add the numerators, negative 53x divided by 30x to the second. So I did my k'ing, my keep the denominator. Now my factor, it still doesn't really factor, so I would still say no. But my canceling, there's actually something here that cancels. I have an x at the top, and I have two x's at the bottom. So I can cancel one off. So this is actually negative 53, and that, sorry, that's not a x. Negative 53, and then the x canceled, so there's only one x left at the bottom. And look, they match. So it really is up to you. The factoring saves you some time. Okay, I'm going to show you another one where if you factored, it saves you some time, but if you don't factor in one like this, like you didn't put the times in, it's still totally legal. Okay, so let me show you what this original problem was. I know you saw it at the beginning, but just in case you wanted to go back, this is what the question looked like in the first place. So it didn't really have the timeses between the 5 and the 5 and the 6x. Okay. So my computer is having lots of notifications, my tablet. I have my old tablet, I have my new tablet, I have my phone, I have my computer, so they're all making noises. I didn't turn off the sound. Okay, so example 4. Example 4. I want to show you an old fraction, but with the new way. It's kind of cool. So let's say that you had 7 divided by 24 minus 13 over 36. Okay, now imagine you're in middle school or elementary school, and you're kind of stressing because you're trying to think, I don't know a common denominator between 24 and 36. Right? So let me show you another way. So let's do it our negative FMDAF way. Okay, I'm not going to suggest this for you to show your younger brothers and sisters this, but for you, it's going to make more sense. When you practice enough of these, this way is going to make more sense than the way that you used to hate doing fractions when you were younger. Okay, so a negative. There is a negative, so I'm going to change that to a plus. Change the sign. Factor the bottom. Now, do you know a factor that goes into 24 and 36? I do. So even though we're not used to really calling this factoring, it is factoring. So how about we call this 12 times and 12 times? Okay, now I picked the greatest common factor. I picked a number I knew that went into 24 and 36. So 24 times what? I mean, 2 times... Let's try it again. 12 times what is 24? I've already said the answer. So that'd be 2. And 12 times what is 36? That's 3. So when you do, I want what my brother has. Hold on. Let me change my brother to blue. I think that's cool. I had to start over on one of my very first videos because I didn't make my brother blue. I was making my brother the first one and then me the second one. And then I was speaking and then it was all backwards. So I started the video. Okay, so what do you think? Look at the yellow. I'm trying to get the blue. So I want what my brother has. My brother has a 12, but I have a 12. So I don't need a 12. I only need a 3. Top and bottom. Now look at the blue. Look over at the yellow. Now all the yellows, including the 3, because the 3 is now yellow. So my sister, she has a 3. My sister, she has a 12. This is my brother speaking, the blue speaking. But my sister has a 2 and I don't have a 2, so I want a 2. So times 2. And then this is 21 over 24. Let's see, 36. 36 times 2 is 72. 36 times 2. 2 carry the 1, 6, 7, 72. Plus negative 26 6 divided by 72. So 72 was the common denominator. So this method makes it so you don't have to find the common denominator at the beginning, because that's the hardest thing to do, I think, personally. Okay, so I matched, I distributed. Distributing just means multiplied, so I did multiply the top, I did factor the bottom, I did change the minus. Add the top, so negative 5. K the bottom, keep the bottom. Factor the top. Top doesn't factor, 5 doesn't really factor. And then cancel. Does 5 go into 72? I don't think so. So this is your old fraction in our new way. Well, it's kind of interesting. I like it. Okay, I don't want to make too many of these videos, like 1, 2, 3, 4 of 7.4. So let me do one more topic in here. And let me call this special cases. I hope you guys all watched the video to this part. Special cases. So what I want to talk about is x plus 3, x minus 3, and 3 minus x. Okay, so I want to talk about all of those, because 2 of them are actually very similar and 1 is completely not similar. And then let's add 3 plus x to the pile. What I want to know is if x plus 3, x minus 3, 3 minus x, 3 plus x, if they cancel at all. So let's just put a sample number in for a minute. Okay, so let's put the sample number in as 10. So let's just say x is 10. So what's the first one turn out to be? What's 10 plus 3? 13? Okay, what about 10 minus 3? 7. Would those have canceled? So imagine you had an x plus 3 at the top and an x minus 3 at the bottom. What do you think? 13 divided by 7, do they cancel? They don't. Okay, so x plus 3 and x minus 3 have basically no multiplying thing in common. So they're their own object when you're doing I want what my brother has. Okay, so a plus 3 and an x minus 3 are totally different. Okay, so that's a sample. So these are samples. Let me write this better. So this is the samples. Okay, so these are my samples. Okay, so what about 3 minus x? What if 10 was here? Well, that's negative 7. So who does that look like? That kind of looks like the second one. Now, they're not exactly the same. What if you had 7 over negative 7, or negative 7 over 7, which is like x minus 3 over 3 minus x, or 3 minus x over x minus 3. So they're very similar. They're almost the same thing. They're the same number, but they're not the same sign. So how would those reduce? 7 divided into 7 is 1, and then I have this negative sign. Now, what if they were flipped over? 7 into 7 is 1, and then there's this negative sign. So these actually cancel and give you negative 1. These cancel and give you negative 1. And then there's another thing that we can do with negative FMDAF is multiplying by negative 1. We'll switch it around. So I'll show you that in the next thing. It's very cool. Okay, now let's look at 3 plus x. So if x is 10, you get 13. Now wait a minute. Is x plus 3 the same as 3 plus x? Yeah, that's the same, right? This is the same. So what if you have an x plus 3 at the top and you have a 3 plus x at the bottom? I'm going to say, well, change the bottom one to change it around. And then they do cancel and leave you with 1. Okay, so let's discuss our new strange case. So x minus 3 versus 3 minus x. They do cancel. So if you have x minus 3 over 3 minus x, that's negative 1. It does reduce. Just cross them out like that. And if you have them upside down, same thing. But what if one of your denominators is x minus 3 and your other denominator is 3 minus x? Okay, so let's have a 5 on top of this one and a 7 on top of this one. So if I look at these, I could say, I want what my brother has, right? So I want what my brother has. So I could say, well, the yellow needs a 3 minus x. And the 3 minus x needs an x minus 3. And this would work. You would get the right answer. Absolutely. It's not a problem. But it will take you a little more work than if you notice this instead. So if you look at them and you say, wait a minute, that's almost the same, what you can do is you can multiply the weird one, the one that looks backwards, you can multiply it by -1. Okay, so let me show you what happens. This one is 5 over x minus 3. This is -7 over -3 plus x. Now, what is -3 plus x? Isn't -3 plus x x minus 3? That's the same thing. Now, usually I'll go right from here to there. I think of -1 times x minus a number. Hold on, let me write it the other way. If you have a number minus x and you multiply by a -1, it switches it to x minus the number. So if you multiplied -1 times 2 minus x, it becomes x minus 2. If you multiply -1 by 8 minus x, it becomes x minus 8. And you can do it for x minus 3. What would that become? That would become 3 minus x. So this is kind of a shortcut feature. Okay, so if you notice it, now if you don't notice it, you can still absolutely get the answer right. So it isn't a required one. So it's a special case, but it's not really required. But it's kind of cool because it saves you a lot of time. So this is add the tops, keep the denominators, and then that would be your answer. Now, if you were going to do it the other way that I wrote with the red and the blue, you get the same answer, you do your distributing, you do your adding, you'll have to factor in step 6, and then one of them will cancel. So it's completely okay, but it's going to look a little strange. Okay, so definitely if you notice, if you multiply by -1, it flips it around. It's definitely going to help you. Okay, we have one more type of problem. On this video I'm using on my new tablet, it doesn't show me, it's kind of strange. It won't show me how much time has gone by, and I forgot to look at the clock. So I have no idea how much time has gone by. So this video might be like super long. Okay, so let me do one more. What example would this be? This is our special cases. That was example 4. This is example 5. So this will be example 6, in case you want to refer to it when you ask me questions. Okay, so I have 7 over 6x squared plus 9 over 19 over 9x. Now there's a couple issues in this one. The first thing is, see this x squared? I feel like if I wrote it 6 times x, it's going to save me some time. So I'm going to write 6 times x, 19 over 9x. So let's just focus on the x's for myself and my brother. And let's write our list. Sometimes I forget to write the list. But remember, I've been a math teacher for a long time, so I know the order without the list, right? So this is the bottom, that's for the top. This is the top, this is for the bottom. Okay, so minus, no. Factor, well, kind of what I just did was factor, writing the x squared as x times x. I wouldn't do that if it was like 6x squared plus 1. I wouldn't write x times x, but the x just by itself, I usually write the x times x. Okay, so I look at that, and what should I do? What do you think? What's the blue need? And you don't have to look at the yellow first. You can look at the blue first. So sometimes I'll look at the blue first. Sometimes I look at the yellow first. I would say the blue definitely needs an x. Now I could have made it have an x squared, and then I could have had this 6x squared just need an x, but it would have been more work for me in the long run, but I still would have been able to get the right answer. Now, how do I make a 6 and a 9 match? One option, and don't write this one down, but take a look at this. You could multiply this one by a 9, and you can multiply this one by a 6. You will absolutely get the right answer. The numbers will just be a little bit bigger, because I don't have to pick 9 and 6, how do you find a common denominator for 6 and 9? Can you think of a smaller number that you could make 6 and 9? Now, if you can't, it's completely fine. Just use the 9 and the 6 like I just wrote. But if you can think of a smaller one, so I'm thinking 6 and 9, how about I use 18? Doesn't 18 go into 6 and to 9? No, 6 goes into 18 and 9 goes into 18. So how about I make them both 18? So if I multiply this one by 3, now you can only match by multiplying. So remember, m is matched by multiplying. So multiply that one by 3, multiply this one by 2, and it does make them both 18. So this m, I call it my brother. That's what I usually use. My bother? No, not my bother, my brother. Okay, my brother, he's older. He's older than me. He's very close to my age, a year and a half away. So he was 2 years older than me when I was a freshman. He was a junior. When I was a sophomore, he was a senior. He's pretty awesome. His name is Greg. Okay, my brother. And then I also have a sister, and she's 10 years younger than I am. So right now I'm 49, and so she's 39. And then my brother's 50. 51. He's 50 because he's just about to be 51 in May. The day after we come back to school. Okay, so my brother, I also called it match by multiplying. Okay, so in this case, the brother works, but also match by multiplying saves me a little bit of time on this specific problem. So this is 21 over 18x to the second plus 38x. I'm on the distributing step. Divided by 18x to the second. So now they match. I add the numerators. Oh, that's interesting. I'm adding the numerators, but there's no like terms. So I guess I'll just put 38x plus 21. And k, what's k mean? K means keep your denominator. Factor. Oh, do I know any numbers that go into 38 and 21? 3 and 7 go into 21. 2 goes into that. I don't think so. Okay, so that'd be a no. So no factoring. So usually that'll mean they can't cancel. So if you were going to cancel at this point, you would have to heart cancel, like quadratic formula. So that's not going to work. It would have to go into all of them, and nothing does. So that's the answer. Okay, so very interesting. I actually should go back to the title of this. I didn't go over any from 7.3. I didn't go over any from 7.3, but I'll try to go over some more from 7.3. And then I do have one more video that I need to do on 7.4, which is called complex fractions. And it's kind of exciting. I might do it tonight too. Anyway, it's kind of, it looks so complicated, but in the end, it really is just like you're doing 3 problems in one. So if you were doing 4 of those, it's like you're really doing 12 problems. So as long as you look at it like that, then it's not so bad. Anyway, now if you had to do 20 of those questions times 3, that'd be like 60 questions. So definitely I want to assign that. You can look in our Google Classroom for the practice questions. And if you want to make any comments, you're going to have to comment in the Google Classroom, or you're going to have to send it to me because right now the videos are blocked from comments. So I apologize for that. Okay, and hopefully I'll see you guys soon. We find out some information from the principal on Thursday. I don't know if you guys are watching this on time. This is Thursday, March 26th. So I'm going to probably text you guys tomorrow in a group text so that I can talk to you and find out what's going on, if you guys are okay. Because you guys didn't answer my question. Only 3 people answered my Google Classroom post from yesterday. 1 answered it today. So it just asked if you guys were okay. Anyway, talk to you later.